Hi and Assalamualaikum. My name is Amirah BINTI WAGIMIN. I am a final year student of Bachelor Civil Engineering Technology majoring in construction. Basically, this project is about reinforced soft soil with pineapple leaf fiber, and this project is under the supervision of Puan Nur Khazanah binti Rahman with co-supervision technologist Dr. Tuan Nur Hasanah binti Tuan Ismail. As we know that soft soil foundation is a popular issue in the world, especially in Malaysia. In addition, soft soil is commonly known as a low strength properties and high compressibility. This is because the sediment process in different environmental area as well as its properties and engineering properties of soft soil, which is vacancy ratio, water content, grain size distribution, compressibility, permeability, and strength show significant variation. The purpose of this study is to determine the strength improvement of the soft soil in area of Pagoh Johor and effectiveness of the fiber. The methodology of this study is start from material collection and preparation. There are two primary materials were used in this study, which is soil and pineapple leaf fiber. The soil sample used was obtained from locally available soil around Pagoh, which was used as a fill material for road construction. The disturbed sample was used throughout the study and was collected at a depth of 2 to 2.5 meter from the ground surface. Then the collected sample were placed into heavy duty plastic bag and transported to the soil sample were oven dried at 105 degrees Celsius for 24 hours. The pineapple leaf fiber is a waste from pineapple tree and was obtained from Nature Recent Johor Bahru as shown in figure. Pineapple leaf fiber are thread-like and range in length from 6 mm to 7 mm and the average diameter 0.07 micrometer. Fiber reinforced soil may be divided into two categories based on their application technique, which is oriented distributed fiber reinforced soil and randomly distributed fiber reinforced soil. The schematic diagram of RDFS clearly illustrate of this technique that has been chosen and are implemented in this study. Reinforcing the soil with fiber can be used to increase the carrying capacity of the soil and the stability of the soil on slope. The benefit of this method include the fact numerous different material may be used to strengthen the soil, which may be because the machinery required is low, affordable, and ecological, and can be used in all soil types. For the result of this study, the first one is the soil sample used in this study can be graded as medium plasticity clay soil with liquid limit more than 50% and plastic index not more than 70%. To achieve the necessary performance, such soil need particular treatment. Based on the result obtained, pineapple leaf fiber has the potential to modify the engineering behavior of medium plasticity clay and make it suitable for road sub-base construction. The second one is tensile strength test. Tensile test sample were prepared according to a STM standard, and testing was performed using a universal testing machine. A tensile test specimen is typically made from randomly selected fibers from single fiber sample. This figure is about the tensile test specimen mounted on paper tap. Based on the tensile strength graph, lower value is 947.9 and the higher value is 2036.62 MPa, which is due to Singha 2020 mentioned that the tensile strength test is range from 413 to 1627 mn per meter squared. The average tensile strength that used in this study is 1259.80 MPa. From this young modulus graph, the lower values for young modulus are 48.17 and the highest value is 85.11, and for the elongation at breaking are in range 2.1% to 3.19%, as shown in this graph. Sinha said that pineapple leaf fiber exhibit a modular selection from 34.5 to 82.51 GN per meter squared, and the elongation at break from 0.8% to 1.6%. Next is the result of compaction test. The compaction result showed that the maximum dry density decreased but increased at 0.5%, and optimal moisture content increased but dropped at 0.5%. The findings shows that the pineapple leaf fiber has been proved as a potential material in enhanced soil efficiency, which is Tom's proof that the direct shear test revealed that the value of cohesion and internal friction increased until the fiber content of 0.75% was reached. The OMC dropped also. The MDD rise at the 0.25 as a result of the machine used during compaction, which caused the soil to become overly compacted and water content to be removed. The last one is CBR testing. The CBR characteristic was used to evaluate the effect of pineapple leaf fiber on established soil strength. In unsoaked condition, the CBR test was carried out by the measuring the pressure required to penetrate the soil sample with a plunger. For each equal layer of soil, 62 blows were used to compact the soil using an automatic compaction machine. Then the water content measured from the compaction test was added. The graph represents the relationship between plunger load and penetration at various path percentage. The CBR value are obtained for the load corresponding at the 2.5 mm and 5.0 mm penetration, as summarized in the table. And the large value is commonly used as a CBR value. The result revealed that the CBR value at 2.5 mm penetration are greater than 0 and 0.25%, that for 0.5 and 0.75% at 5 mm penetration. A CBR value of stabilized the soil shown in the graph for different pineapple leaf fiber percentage, which is 0, 0.25%, 0.5%, and 0.75%. As can be seen by the curve, the CBR value has improved but dropped at 0.25. From this, it can be concluded that strength of stabilization soil increased with increasing percentage of pineapple leaf fiber due to the high value of CBR penetration is at 0.75%. As a conclusion, the influence of pineapple leaf fiber combined with problematic soil was explored in this study, which also analysed the clay soil characteristic and conclude the analysis on idioharpago soft soil. It can be concluded that the objective of this study have been achieved with successful finding. The CBR value achieved the highest value at 0.75% of pineapple leaf fiber content. The finding shows that the pineapple leaf fiber has been proved that a potential material in enhanced soil efficiency, which Tom's proved that the direct shear test revealed that the value of cohesion and internal friction increased until a fiber content reached to 0.57.